Okay, so hope everyone's doing well. What I want to do is I want to move on to a new topic in the graphics syllabus. Okay, so I want to move on today to what's known as transformation geometry. Okay, so it's on page 88 in your books, and we're going to be doing a question on it. Okay, so what is transformation geometry? Okay, so basically transformation geometry it's a general term given to a collection of operations that involve the manipulation of a shape or object. So basically what it is taking an object or a shape or something and moving it in different directions or different orientations depending on the transformation that they're asking us to do. Now, in transformation geometry, we have four different types. We have what's known as translation, we have axial symmetry or reflection, we have rotation, and we have central symmetry. Okay, so just have a look at them and see what they actually are. Okay, so we see the first one is a translation. Okay, so here we have this butterfly here. A translation is this is the original image here on the left hand side, and a translation is basically I'm just taking that image and I'm moving it along a set path to another. So see this red line here, I'm just basically taking this image and sliding it along that line up here. The orientation of it does not change and the size does not change either. Okay, so if we have, let me see. Okay, so examples of translations. Okay, so here we go. So we see the image here, we're taking it and we're basically sliding it into its new position. Okay. The next one we look at is what's known as axial symmetry, and axial symmetry is basically just like a mirror image. Okay, so it's like if we take an object and what one side is going to look exactly the same as the other side. Okay, so we'll take this image here as an example, and we see that we're just basically taking it and flipping it over across a line of symmetry in the center, and it's going to get us the exact same image over the far side. Now, so just looking at the first one we're going to look at today is what's known as translations. Okay, so translation is to move or copy a shape or object in a specific direction at a set distance. Okay, so what does this mean? We're going to have a look at question or the example in our books. Okay, so example 8.1, it's on page 89. A translation is where you move a shape or object in a certain direction a set distance. The object will remain the same shape and orientation as before the translation, just in a new position. This is a very useful technique used to easily copy shapes or curves that appear more than once in a drawing. A direction vector is a line that has both direction and length. The direction vector for a translation is a distance and direction the object is to be moved. Okay, so now there. Let's have a look at this question here. Okay, so it's example 8.1 in your books. Okay, and I'm going to draw it out on the page here as well. Okay, so we see I'm just going to draw it in and I am coming down 110 millimeters and I'm coming in 60 millimeters in order to get the starting point. Okay, so down at 110 millimeters from the top on my border, and I'm coming in 60, and that's going to get me my starting point here. I'm just going to draw it in the image quickly. So what have we got? We have the length. So we know this box on the bottom is 26 by 26. It's a square. So I'm going to draw it in, and I'll get the dimensions of it. Okay. Now, so it's a square and it's broken up into 4 different parts, so I'm going to just draw the center. So, okay, make sure your pencil also is nice and sharp. Okay, so just to write that in, actually, I came in 60 millimeters, okay, from the edge and it came down 110 millimeters from the top. Okay, and that got me my starting point here, which is A. Now, so drawing in the rest of the shape. Okay, so what else have we got? I've got the square drawn on the bottom. Now I need to find this line here. Well, I know from the center of the square, okay, which is this point, I know I'm going to have to come up 25 millimeters and I'm going to have to come across 25 millimeters, okay, because I know that the distance across is 50, so the distance from P over to here has to be half of 50, which is 25. Okay, so I'm going to measure over 25. Okay, and I'll draw in that line now. Okay, and I'll just get that line on the point on the far side. Okay, now so to draw the top section then, I know it has the overall diameter, okay, of the semicircle is 50, so the radius has to be 25. Okay, so it's the width that I have drawn in here, so I'm going to draw it in with my compass. Okay, and then there's these other little sections also. Now, so I'm just going to give it a little bit of colour just for the video. So the bottom was in red, or just a little. Okay, and I'll just colour these in as well. Okay, so a little bit of. Now, okay, so this image here now I have it drawn, okay, so I want to produce a translation of this image. So what have we got here? I also need to find this point P1, okay, because I need to construct this image, and basically I need to slide all this image across from the point P to P1. So I need to also find point P1, okay. I know it's at a 30, okay, I'll label this point here. It's point P. I know to get P1, it's at a 30-degree angle. Okay, so I have my 30-degree set square, which I can use, and the length of that line is 85. So I'm going to come along, draw a line out, and the length of that line is 85 millimeters. Okay, so there we go. And here we go. So that's get me that point here, which is P1. Okay, so now what I need to do, I need to take this image and I need to slide it along this line so that the point P is going to be located at P1. So I'm basically taking this image here now and sliding it in this direction. Now, so how am I going to do this? The first thing I'm going to do is I'm going to break my to break it up into different, and I'm going to label different points so I don't get confused. So each of the kind of corners on my square, I'll label them. So this is A. I'll call this one B. Okay, I'll continue with the same as the drawing. Okay, so this one B, C, and I'll call this D, and this is A. Okay, so the same as the question. Now, and we'll label a few more, so to have this called E, F, G, H, I, and J. Okay, so basically what I'm doing is each of the kind of corners and different points I'm after label them. Okay, I didn't draw the center point because I know if I just join these two lines that get me the center, so I don't have to translate that over. Okay, so that's the same. Basically what I have here now is what I have in the first section of my drawing here. I need to slide all these points over, so I'm going to have to draw lines parallel to the P1 line. Okay, so each line I'm going to draw now is going to be parallel to that line. So let's take, for example, that's P. I'm going to start off and we'll go in alphabetical order. So I'll take this first one as A. I want to draw a line that's parallel to this P1. So from A, I'm going to come parallel. I know that has to be parallel because this line's at 30 degrees and I'm also drawing this one at 30 degrees. Okay, so how do I find, I know that point A is somewhere along this line. How do I know whereabouts? I'm taking the distance of P to P1. Okay, so translation to set distance. And now from A along the parallel line I constructed, I'm marking the line off. Okay, that's going to get me A1. Okay, to get B, I'll do the same principle. Okay, so from B, I'm going to draw a line. This line here is parallel to this line and also to this line. I have my compass set already just to show you. So it's the length of P1. I'm going to put this on B now. I'm marking it off on that line. That gets me B1. I'll do the same for C and D then. Okay, so C and D. So this is C1 and D1. Okay, now, so if all these points are joined up here, they have to be joined up in this one. So, for example, A is joined to B here, so A1 is going to be joined to B1. Okay, B is joined to C in this view, so B and C are going to have to be joined in this one. Okay. And that's the bottom section of it completed. Okay, I'll do the rest now, so just get the rest, get point E. Okay, I know E is along the line AB, so if I just draw that now until it intersects that line, that will get me E. Okay, so I'll do the same with H, J, okay. Okay, so H1, E1, I1, J1. Okay, so now. Okay, so now I have the bottom section of it completed. Okay, so if this is the orange section here, I'll just color it in as well. Okay, so now we need to get the top section. Okay, so what do I need? I have E already, E1, so I need to get this line here. Okay, so I need to find a point F. I need to find F1 in the translated view. So again, I'm going to draw a line parallel to this. It's at 30 degrees along. I'm going to get the distance from P to P1, that's my standard length, and I'm going to find this on the F line. Okay, so that gets me on the same line, that's F1. Also need to find G. Okay, and that's going to get me G1. Okay, so now I can draw in. I know that E joins to F in this view, so E1 will have to join to F1 in the new translated view. Okay, E joins to G, so E1 is going to have to join to G1. Like that. Now, so I'm almost finished. I just need to draw in the rest of my points. So I see that this joins to here. Okay, and now, because in a translation, I know the orientation or the size does not change. Okay, so I know if the radius in this circle here, or this view here, was this size, okay, it has to be the same down here. Okay. Okay, and now I'll just and now we have it. So what I have done here now is I've created a translation view of my original image from the point P to P1. Okay, all my all my lines I drew were parallel. So from each point, I drew a line parallel to P1. I knew that that line from my question was 30 degrees, so I could just draw a 30-degree line from each point. I got the length of P1, and each of the lines, so for example line A, on the parallel line I drew, I marked that distance off, and that got me A1, and I constructed the rest of this these. Okay, so the same principle applies for all these questions, no matter what the angle is. So for example, P to P1, it could have been going in this direction, or it could have been going in this direction, or straight up, whatever, it doesn't make a difference. It's the same principle applies.